Hello and welcome to another one of D's ADD videos. Today we're going to look at some VESPR examples, and they're slightly more complex than the last ones. Let's see what we got going on here. H2O, if you do the proper Lewis structure, you should get something that looks like this. Hydrogen on the outsides, lone pair, lone pair. Alright? So that's 4 domains or coordinates or whatever you want to call them. 2 of which are atoms, so they're bonding domains, the hydrogen, and 2 of which are lone pairs. So if we go to your handy dandy chart and we look, 4 domains, 2 of which are bonding domains and 2 of which are lone pairs. And the electron geometry, anytime it's 4 domains, is tetrahedral. Okay? And if it's 2 lone pairs, it's bent structure, and it looks something like this. So 4, then we have bent right there. Okay, that's going into the page, that's coming out. So we have the oxygen centrally located, and then we're going to have the 2 hydrogens, 1 lone pair going in and 1 coming out. Okay, and the EPG is going to be tetrahedral, and the MPG is going to be bent. The bond angle normally on the tetrahedral is 109.5, but all these lone pairs push down, making this bond angle, I think it's roughly 104.5, but it's less than 109.5 is the main key. Alright? So you can see that you need to be proficient in your Lewis structures as well as have a lot of stuff memorized. Make note cards. The quicker you start, the better off you'll be. Alright, the next example we're going to look at is SF4. If you do the Lewis structure for this guy, it's going to be and I believe there's 2 lone pairs there. So here we're going to have 1, 2, 3, 4, 5 domains. Then we're going to have 4 of them are bonding domains, 1 lone pair, and that equates to the shape of, so we've got 5, and it's 4 and 1. Anything that's got 5 domains has the EG, or the basic shape of trigonal bipyramidal. But the molecular geometry differs depending on how many sets of lone pairs we have. And here we have what's called the seesaw. The seesaw, some people refer to it as a distorted tetrahedral shape. The common name is seesaw. You can see you got a bunch of bond angles there. Let's see what it looks like. So I probably need to zoom in here. So here we've got the 5. All of these are trigonal bipyramidal. And we have this basic shape here. 4 elements. Okay. The bond angle between these 3 should be 120. But it's not. So let's check it out. Let's get it done. So I would need a fluorine up here, a fluorine down here, 2 fluorines over here, a sulfur right there. This fluorine will be coming out at you. This fluorine is going back into the page. These are on the same plane. Then you have your lone pair right there. Okay? So at this point, what happens is this bond angle, do the bond angles in a different color. So if there was an element right here, that would be considered a bond angle. But since these are lone pairs, there's no bond angles to have. But if, let's say this was another fluorine, for instance, that would be 120 degrees, this would be 120 degrees, and that would be 120 degrees. But since that's not a bond, we can't call it a bond angle. But this, that should have been 120 degrees, now is less than 120 degrees. This bond angle is 180 degrees. Actually, this one should be less than 180 as well. All right. So again, the bond angles are less than their original angles that they should be if there was an element here, because the lone pairs have a slightly wider electron density than just a restricted bond angle. So they push bonds back that way. The bonds are formed by 2 electrons, and these electrons repel each other. So the EPG for this one's going to be trigonal bipyramidal. The molecular geometry, or MG, is seesaw or distorted tetrahedral. So practice, practice, practice is the most important part of this. Knowing your shapes and all that will help. And try these 2. This is going to be the next video, the more advanced video. And thank you, and have a nice day.